We have a new topic today, and before discussing, I would like to say thank you to everyone who kept on watching my newest video. And if you are new to this channel, please try to hit the bell button below and subscribe so you can link to my next video. Okay, our new lesson today is all about complete and incomplete circuits. So at the end of this video, you will be able to, number 1, explain that electricity is the movement of electrons from one place to another. Number 2, explain how electricity flows in currents. Number 3, recognize that a complete circuit is when electricity flows continuously, and an incomplete circuit is when electricity flow is disrupted. Finally, determine that a switch can make a circuit complete or incomplete. Now, what would your world be like without electricity? Think about it. Electricity is a very useful form of energy. It can be changed into other types of energy like light, heat, and movement. Think about all the ways you use mains electricity in your home. You can turn on lights, boil the kettle, take a shower, or blow dry your hair. Or you can watch TV, you use your computer, and warm food in the microwave. The ways we use electricity are too numerous to count, yet we take it for granted. Just imagine it being able to do any of these things. Well, in our modern world, though we can, but it's hard to live in a dark place or without electricity. So in this video, you will learn to embrace how important electricity is. By definition, electricity is just the movement of electrons from one place to another to create power, light, or energy. It is something that we would have a very hard time living without. Electricity that flows is called a current. A current of electricity can only move in a complete circuit. To illustrate how a complete circuit works, let's use the typical components of a complete circuit as shown in the picture: a battery, a wire, and a bulb. Electricity flows from a battery's negative terminal through the bulb, then to the positive terminal, and then through the battery and back to the negative terminal. This is a complete circuit. This continues as long as the circuit is complete because a circuit has no beginning and no ending. When the circuit is disconnected with any of these parts in the path, then an incomplete circuit occurs. Try to look at the difference as shown in the diagram. These are the examples of complete and incomplete circuits. With a complete circuit, the electricity can make a light bulb work, start an electric motor, and make other electrical equipment work. When you connect a bulb to a battery with 2 pieces of wire, it lights up. This is a complete electrical circuit. A circuit needs to be like a loop with no beginning and no end. The battery pushes the electricity through the wire and makes it flow around the circuit. You can vary the current by putting more batteries in the circuit. Make sure you connect negative to positive on each battery, keeping the circuit complete. The more batteries you add, the brighter the bulb will shine. If you add too many batteries, the bulb will burn out because it is not made to withstand so much electricity. When you turn on a light, you usually use a switch. A switch is something that forms a bridge to close a gap in a circuit. An electric current cannot flow across a gap, so it needs something to make a bridge or gate to close the gap in the circuit. A switch does that for you. Sometimes, a switch can be added to a circuit to change it from a complete circuit to an incomplete circuit, and vice versa. When the switch closes the gap, then the circuit is closed. Thus, the electricity will flow. This is a complete circuit. When the switch is open or there is a gap in a circuit, the electricity won't flow. This is an incomplete circuit. Try to look at the diagram. This switch is off now, so the light bulb won't work. Look at the gap in the circuit. When you push down the switch, the gap will be closed and the switch will be on. The electricity will flow through the circuit and the light will work. The circuit is now complete. Now, why do you think switches are made of plastic? This question will be answered in our next video. And that ends our discussion for today. Please don't forget to answer workbook pages 117 and 118. If you learned something today, please don't forget to hit like, share, and subscribe. My name's Miss Noreen Sikabasa. Have a great day!